computers, and what are the main challenges to construct a quantum computers?
Okay, very good question, and I think I'm very really I am very what I can say, I'm very excited that you in the level one of computing, you are studying and you are thinking in the line of computer, which is the computer of the next generation. Okay, okay, it's a quantum computer is a change in the paradigm in the terms of computer system architecture as well as computer algorithms. Right, there are two parts of it. One is computer system architecture. One is the algorithms what you can build up on quantum computers. Okay, so this paradigm actually exploits the quantum mechanical phenomenon which are there in the atomic level, right? Because the present day computers, which are actually built with transistors, right? They still follow the classical electrodynamics, right? They still follow the classical electrical properties of matter, which are called bulk properties. So there are some limitations. So there are two things why we move to quantum computer. Why we will move to quantum computer gradually, right? First thing is that the way the device sizes are getting squeezed up. The present transistor size is actually 8 nanometer. 8 nanometer transistors are being now manufactured, okay, by the very super specialty laboratories, right, like TSMC and FASTAC. So we see that in that level of transistors, we are already in a one atomic or two atomic layer of devices. So in that particular dimension, okay, there is a choice that whether we still follow the classical principle of electrical engineering, bulk properties of matter, or I will go to the discrete properties of matter, which is quantum. Okay, first. But if this is the only interest that, okay, as we are squeezing down the size of our devices, I will essentially hit the quantum regime and so take up quantum. It's not only the thing. The quantum mechanical phenomenon, which gives you some new operations like superposition, interference, and entanglement, right, helps you to develop algorithms which cannot be taught in the classical domain. So, so there are two directions, as I told. One is the system, which the quantum computer can give you a large amount of computing power using a very small number of atoms. Because I will just tell you why. Because the computing power in a quantum state, okay, increases exponentially. So which means that if you have n resources, which are called n qubits in quantum computer, right? Right. If you move from n to n plus one, right, your resource will be increased, okay, by 2 to the power n to 2 to the power n plus one. So you see there's exponential increase in the resources. This is in the case of classical, the resource, if you have an n register and replace it with n plus one register, your size of the data will be from n to n plus one. So you see that you can represent a larger amount of computing space with smaller amount of resources in the computing domain. And the second one is that apart from this, you have some of the techniques in the quantum mechanical domain, which actually gives you some betterness in the algorithm. Last but not the least, quantum computer machines are not now only somebody thinks or somebody have some idea. They are in reality. Quantum computing machines are in reality, right? IBM has it, Google has it, D-Wave has it, Rigetti has it, Atos has it. Okay, I have yesterday I saw that Tata Honeywell also has one quantum computer. They have built one quantum computer machines, but there is one difference. Quantum computing machines will not just like desktop or laptop, what we are common. Quantum computing machines will be mostly at the cloud. So it will be offered as a service. So if you want to crack if you want to generate a drug uh, for your COVID-19, you have to do a huge amount of search okay, among the drug molecules. It's a complex problem. Okay, you push it to quantum computer in the cloud, right? So quantum computing paradigm at the present point of time will now come up into the business problems, will now come up into the scientific problems. And that's why the pioneers like Microsoft, Google, uh, IBM, right? They have already taken the path and they have already established very well defined activities in this domain.
Wow, thank you so much,
Okay.
sir.
Okay. Yeah.
Any questions from student?
Sir, good evening, sir.
Yes.
Sir, actually, I'm very glad to know your taste of computer science, sir.
Mm-hmm.
Yes, sir. And I want
My
taste of computer science.
okay. Okay.
Yes, sir. And sir, I want to know, sir, can you tell something more about cloud computing?
Yeah, I can go on and on. Okay.
Yes, sir.
Okay. So cloud computing is something. It's actually, that means when we started in research, okay, distributed computing was very strong, right? And computer network was in our courses also. Distributed computing was not there in my courses, but some of us, like some of the students like us, were just trying to see that what are the applications of computer networks, and we find distributed computing. But when we started research with our student, we found that the emerging thing is cloud computing. So cloud, what is the cloud? You just try to think, what is the cloud? Cloud is something which, that means, suppose in 4 o'clock I see a cloud which is there of a smaller size. Maybe at 5 o'clock I see that the cloud size gets very larger, right?
Yes, sir.
And the shape
Yes,
also
sir.
gets changed. So that is
Huh.
the concept of cloud, which means that, and it is a concept of virtualization, which means that there are several distributed resources across different corners of the world, right?
Yes,
Now,
sir.
in a way that these distributed resources can be visualized by a user as a single entity, but this entity will not be a sort of limited by any number or count. Okay, this is according to the requirement of the user. So a user can tell that, hey, I want 24 computing nodes to serve me. So your cloud service provider will organize 24 computing nodes with the specification what the user requires. Now these 24 computing nodes will be virtual nodes. Now these 24 computer nodes may be realized with maybe 10 data storage, okay, or maybe 5 big computing nodes working somewhere in the world, okay,
Hmm.
which can be virtualized by the cloud service provider, like the way that big cloud service provider, Google, Amazon, Microsoft, they are spread all over the world. So but this is a very good in the user's perspective, in the sense that, suppose a business house, okay, wants to have a good performance computing in his for his own business purpose. The one way is that he will install the computing in his own premise. Okay, he will employ the system management people to monitor this. But might be, if we see the system load, might be the system load is only reaching 95% when they're at the end of the financial year, or they are in a particular period of the financial year. In the rest
Hmm.
all, they are only using the maximum capacity, 20% or 25% of maximum capacity. So if you estimate the loss in terms of investment, in terms of maintenance, in terms of energy, which is spent for the infrastructure, right? The business house will surely tell that this is a loss for us. Now, what the business house can do? Business house can actually connect with a cloud service provider. In a cloud service provider, it is pay as you use. So you tell me that, okay, and this charge is also varying. When there are so many users on your cloud, then if you try to get a resource, your resource will be costly. It's a very beautiful revenue model, which has also been researched very well. If you want to know the revenue model of the cloud, very good person is Dr. Shomo Sen of University of I think I'm not good. I will give you just kind of offline. He was a postdoc in Princeton when I was doing a postdoc with in another group, and he was doing in that group. So Professor Mung Chen of Princeton University is one of the a pioneer on proposing this cloud revenue models, right?
Yes, sir.
Yeah. So Dr. Shomo Shen, University of Minnesota. So now I remember. Okay, he's a
Okay,
good
sir.
friend of mine. So these are the cloud revenue models which helps an enterprise to get the resource as it requires, and also the pricing varies as per the it's a dynamic pricing concept. It always so any dynamic pricing, the way it works, it's a both benefit to the service provider and both benefit to the user, right?
Okay,
So
sir.
that
Yes,
way,
sir.
that way he or she, that means the enterprise gets a benefit in the pricing, enterprise gets a benefit in the usage of the system, and the cloud service provider is not only supporting one enterprise, the cloud service provider by expanding and contracting its resource space, okay, are surfacing number of provider, a number of users over a given point of time. And that's the beautiful. So cloud itself, okay, incorporates computer science, incorporates economics, incorporates networking, right? Incorporates security. So many things associated with the cloud.
Yes, sir.
Yeah.
Okay, sir. Thanks, sir.
Thank you.
Student, any question?
More questions from students?
Last of all, actually, we are end of this program,
Yes.
and we are very happy to Professor Amlan Chakraborty is with us, and he has a lot of experience in practical field and theoretical field of this modern field, by emerging field of the computer science or information technology and like this. And the students actually afterwards, I invite him afterwards when this pandemic situation is normal under our control. Then he previously came our college and also give talk and interact with the student, and also one or two student of our college also he has done project under him. He's a very good teacher and very good experience in project and other practical field. So you student, those are actually in a newly admitted computer science, you have a lot of field you can understand, and you can get lot of support, just like Professor Amlan Chakraborty. So you don't worry that your journey will be safe because many are with you. So don't worry. And in future, we are also hope to get also the help of the Dr. Amlan Chakraborty, and he helped lot of way. I do not tell you because he is closely associated with our college and with our department. And so we are very lucky that this person we are with you. So with these few words, I extend our heartiest regard to Professor Amlan Chakraborty on behalf of the college, on behalf of the department, all the faculty members, and the students, especially you, those are newly admitted students, those are present. So I welcome and also extend my heartiest regard to him. And also I tell sir that in future, when this thing will under control, sir, please come again our college and interact them this face to face, not this virtual field. But virtual field, what can we do? We can also enjoy, because every classes and everything is going on. Theory class, everything are going on, and the students are also accustomed. Sir, what can you tell? This virtual field also one type of field. We have to accept in future.
I am not very that means what I can say. I will not and that means say that the virtual is very good for the students. Maybe
Yes.
for some of the students it's good, but I think always the class with the board is the best way. But
Yes, sir.
within this environment, what we can do, that means still we can offer at least our best with the virtual. That's only the virtual platform. But
Yes.
still the classroom is the best.
Best.
In my
Yes.
opinion.
Yes. It is because of eye contact, this personal
Yes.
interaction.
Yes.
These are actually lacking because all we are
Yes.
sitting different place. This
Yes,
actually
and also I think it's a sort of it's a bit boring sometimes in
yes,
virtual.
yes,
Boring. I
yes,
mean,
yes.
it's a
Nobody in front of.
same posture of your professor.
Yes,
Okay, either he's sitting in somewhere. Okay,
yes,
and in the same posture he's delivering
yes.
everything. It's a very monotony.
Monotone.
Okay,
Yes, yes,
but for good students, they want to abstract some core ideas. It's okay.
yes,
But
yes,
for some of the students where you need to interact with them, you need to see that whether they're getting into the things or not. Again, also especially the subject in computer science requires a lot of mathematics. So
yes, sir.
sometimes if I just write mathematics, the students will not understand. I have to tell that okay, this term tells this, and then I go from term X to term Y, and I tell
Yes.
okay, in background you have learned this, and to
Yes,
just try to recollect this. So these things are pretty difficult in the
Yes,
virtual
sir.
world, we find.
Yes, sir. Yes, sir. And we cannot understand actually what is the this hot thing actually taking a student. What actually
Yes.
taking a student in different
Yes.
sections of the students are present in the
Yes.
class.
Yes.
It is very difficult. Yes.
Yes.
So what can we do? So we have to wait 2 or 3 months, maybe. Maybe I do not
Yes.
know.
Maybe. If we are very lucky,
Lucky.
lucky,
Yes.
we can start
Yes.
everything within next 2-3 months.
Yes.
Okay, let's all pray to the Almighty.
Yeah.
Okay.
Yes.
Okay, that the things this will go out of our
Yes, sir. Yes.
world, of the entire world, not only our country but entire world.
Yes. Entire. So, sir, thank all of you.
No,
So
thank you, Swamiji, for
valuable time for us.
thank you, Swamiji, thank you.
Thank you, sir.
Thank
you, sir.
you. Thank
It
all
was
to the
a
students.
very
Okay,
inspiring lecture.
be
Yes.
happy, be safe. Yeah.